Hello and welcome to this lecture. This is chapter 12 of D3 of New Syllabus Mathematics for O-Levels, and this is the 6th edition. We are doing the difficult questions from selected chapters, and in chapter 12 the most difficult questions occur right at the end of the review questions. So we are going to be starting with question number 9. Right then, here is your figure in which a circle is enclosed in a sector of another circle. Now, the radius of the larger circle is 48 centimeter, and you should be clear that OA and OB are the radii of the larger circle, not the small r. Small r is the radius of the smaller circle which is enclosed in the sector. So you have to find this r, and also you have to find the area of the shaded region. We draw a line from the center of the smaller circle to the place where the larger circle forms a tangent and cuts the circle at the point Q. We call the center of the circle X, and we draw a similar line from X to point O, the center of the larger circle. Now we know that since O is the intersection point of both of the tangents OA and OB of the smaller circle PQR, then it means that a line drawn from the center of PQR, the green one, to O would bisect the angle BOA, that is 60 degrees, and divide it exactly into two halves of 30 degrees each. We also know that angle OQX is 90 degrees because QX is the radius and OA is the tangent to the circle PQR. And whenever the radius and the tangent interact, they have an angle of 90 degrees between them. Now let me label three distances. QX is R, and we also label R and X as two parts of the line OX. But let us extend that further. Since XR is also the radius, we can say that OR, the radius of the largest circle, equals OX plus small r. And we know OR is 48. And we can say that x plus 2r equals 48. Here I've shown all the radiuses. Here I've shown all the radii. Now consider the triangle OXQ, and you'll find that the angle OXQ is 60 degrees because sum of angles in a triangle is 180. Now we apply the sine rule and note that sine 90 over x plus r equals sine 30 over r. You can use that to find the relationship between x and r. And we find that r actually equals x. We put this in our equation that we found first. 48 is equal to x plus 2r, which gives us the value of radius to be 16 centimeters, and that is our answer. Now let's move on to the next part, that is the area of the shaded region. We first apply the sine rule again and find that OQ equals 16 under root 3 centimeters. Using that, we can find the area of the triangle OXQ. Next up, we place a point J in the diagram, and it is on the line OX. J is basically the intersection of the circle PQR with the line OX. That is the point where the circle and the line first meet. And we find the area of the sector QXJ to be equal to 60 divided by 360 multiplied by pi into 16 squared. Remember that area of a sector is lesser than the area of the whole circle in proportion to the angle that subtends the sector. And here the angle is 60 degrees. So area of the part QOJ, that is half of the shaded region, comes out to be 87.7 centimeter squares. We simply subtract the area of QXJ sector from the triangle OXQ. Now area of the shaded region is twice of the area of QOJ, and it comes out to be 175.3 centimeters square. In the next video, we are going to be doing the last question of the review questions, number 10. The link of the next lecture can be found in the description. Once this video finishes, you can click on that link and we can start that lecture. Thank you for watching.